Hey everyone, good morning. I'm Mr. Willis, and I'm a chemistry teacher here at Lufkin High School, and I wanted to talk with you today about acids and bases and pH. So let's spend a few moments talking about that. All right, here we go. Let's see, and click. All right, so as we talk about acids and bases and salts, so when we talk about a salt, that's just an ionic compound. So we're really going to focus today on acids and bases. Now, an acid is something that releases a hydrogen ion anytime that it dissociates or breaks up in water. So here we can see a hydrogen and a chlorine. That would be hydrochloric acid when it's in water. And that's a very common acid. It's a very strong acid, which means that when it is in water, it breaks up and separates into a hydrogen ion and a chlorine ion. And so it breaks up and releases that H plus. And so releasing and producing that H plus is what makes this an acid. Now, that H plus that was just released will then actually, since it's in water, go and join with water. And so here we can see H2O. We've got two H's and an O there, and then when it joins in, it will make an H3O, which is actually called a hydronium ion. Okay, but really, what you'll see talked about and what you need to remember is that H plus. Nothing special has to happen once that gets in the water. It will automatically convert to H3O. But you just need to remember that having those H pluses is what makes something an acid. All right, and so again, an acid can be defined as something that produces an H plus or that produces a hydronium ion, because once that H plus is produced in water, it will join water and make that hydronium, make that H3O. All right, let's write down a couple of properties of acids. When we say it's a property of an acid, we mean that this is a characteristic. It tastes sour, like if you take a lemon out of your tea and just chomp on that thing, it will make you pucker and make your cheeks touch together in the back. And so lemons, jawbreakers, Sour Patch Kids, vinegar. Hopefully you're not drinking vinegar. That would be nasty. And some of your sodas. Okay, but anything that has that tastes sour, that has a strong acidic flavor to it. Um, let's see. Most of your citrus fruits will have citric acid. Oranges, lemons, limes, and all those are going to have a little bit of a sour taste and a little bit of an acidic taste. Again, acetic acid, which is the same as vinegar. Ascorbic acid, if you just eat vitamin C tablets to try and stay healthy, that's something some people do, and it will have a sour taste also. Another property of acids, so the first property is that they taste sour, and there's some examples of some acids. And number two is they react with metals to produce hydrogen gas. And so if you have an acid like hydrogen, like hydrochloric acid, and mix it with just a metal like magnesium, which is what we're showing in this case, the magnesium will actually bump the hydrogen loose, and the magnesium will replace the hydrogen with the chlorine, and then you'll have H2 or hydrogen gas. So that is another characteristic of acids, is that they produce hydrogen gas when reacted with metals. A third property of acids is that they conduct electricity. I'm not sure if you know or not, but pure water does not actually conduct electricity because it needs to have electrical ions in order for that electricity to conduct through the water or through the solution. Acids do that. Now, if we were to look at this, both of these light bulbs are actually on. It's hard to tell on this picture because it's a little dim, but both of them are on. So which one do you think is the stronger acid? Okay, and if you said the left one, you would be correct, because since it is stronger, it has more ions moving around in the liquid, and it is able to conduct a greater electric current. Let's see, so examples of acids: vinegar, fruit, specifically citrus fruits, sodas, any food containing fruit juice or vinegar, and of course car batteries. Car batteries have sulfuric acid in them, nasty stuff. A strong acid. Okay, so you may hear people talk about if an acid is strong or weak. If it is a strong acid, that means that it dissociates or separates completely in water or in a liquid and forms lots and lots of hydrogen ions, which of course then transform into hydronium ions. Um, so the thing to remember is that it breaks apart completely, okay, and so forms lots of hydrogen atoms. That is going to be a strong acid. So if I tell you that, what do you think a weak acid would do? Well, it would be the opposite, which would mean it would not break apart completely and produce only a few hydrogen atoms. So strong acids do break apart completely, weak acids do not. Strong acids produce many hydrogen ions, weak acids produce few, and therefore only a few hydronium ions. All right, we're going to leave acids for a moment and talk about base. Not base like you would hear in the back of your car. That would be with two S's, B-A-S-S, but base as in the chemical substance. All right, and so that's B-A-S-E. So a base is a substance that releases hydroxide ions, or OH minus. Remember, acids were H plus, bases are OH minus. They will release OH minus or hydroxide. And sure enough, one acid, one hydrogen, but they are bound together in a single ion and act together as a team. Properties of bases: they taste bitter. If you have ever gotten soap in your mouth, that bitter taste. Also, they are a little bit slippery. So again, if you think about soap, soap is a good example. All right. And so here's some other examples of bases. Tasting bitter and feeling slippery are two of our properties. Again, you can see the cocoa powder. So the cocoa powder and the baking soda and any of our bases will taste bitter, and they will also tend to feel slippery. Dishwashing liquid, ammonia, oven cleaner, different lotions, and soaps. So all of those are examples of bases. Bases also conduct electricity, and they also dissolve fats and oils. That is what helps our soap and detergent to work so well and get dirt out of our clothes. Is the fact that it is nonpolar and also happens to be a base. So both of those things help. So, and it conducts electricity just like the acid does because it still has lots of ions. They are different ions, but it still has many ions, especially if it's a strong base. So some examples, again, soap, bleach, detergent, ammonia, Windex, and lots of our different cleaners. So let's talk about strong and weak again. Remember that strong means that it breaks apart completely and easily, or dissociates easily, and produces many hydroxide ions, whereas weak bases do not dissociate completely and produce few hydroxides. So if that substance breaks apart almost completely and produces a lot of hydroxides, it's going to be a strong base. If it doesn't, if it only partially breaks apart, then that will be a weak base and it will produce only a few hydroxides. All right, so we've talked about acids and bases, and in between those is neutral. And a neutral, remember that acids have a lot of H plus, bases have a lot of OH minus, and if you have the same amount of each, then that will be a neutral solution. And of course, the best example of a neutral solution is pure water. See, formulas for common acids and bases. It's extremely common for our acids to begin with an H, like hydrofluoric, carbonic, phosphoric, and so H2CO3, H3PO4, HF, HCl, all of those begin with H, and that's a great way. If you see something that begins with H, it is almost certainly an acid, with the exception of H2O. Bases end with OH or hydroxide. So again, potassium hydroxide, KOH, MgOH2, magnesium hydroxide, aluminum hydroxide, AlOH3. So again, just as starting with an H would make it an acid, ending with an OH almost certainly means it is going to be a base. An indicator is something that helps us to understand if we're dealing with an acid or a base. It helps us to detect the presence of acids and bases. And what I'm going to focus on, it turns out that these indicators are substances that will change colors in the presence of either H plus or OH minus ions. And so they are sensitive to those ions and will produce a color change. This is one called phenolphthalein, and it actually turns pink in bases. So anything above a pH of about 8, and we'll talk about the pH scale in a moment, anything 8 or higher tends to make it a little bit pink, whereas in an acid it remains clear, or in a neutral solution it remains clear. Let's see, we are going to skip that page. All right, one great way to find the pH of a solution is to use pH paper, which is where you would take a little strip of paper and put it in the solution and then read the scale on the bottle. If it has a pH from 1 to 6, that is going to be an acid. 7 will be a neutral pH, and 8 through 14 will be a basic solution. So if it has more H plus, it's acidic and will have a lower pH. If it has more OH minus, it will be basic and have a higher pH. And if it has the same amount of H and OH, it will be neutral and be right there in the middle at 7. So real quickly, if you look, we've kind of got some words stuck on top of each other here. 0, 1, 2, and 3 are what we would say are strong acids. 4, 5, and 6 would be a weak acid. 7 would be neutral. 8, 9, 10 would be a weak base, and then 11 through 14 would be a strong base. And so that's just a quick breakdown of how those numbers will fall out. And of course, you can see that there. Here are some examples of different acids again and their pH. Remember, again, an acid produces hydrogen more easily than water. And bases produce more hydroxide and actually are able to absorb, to take in hydrogen and form water. So let's see. So yes, stomach acid, extremely acidic, pH of 2. Lemon juice and vinegar, pH of 3. Soda and tomato juice, pH of 4. Plain coffee, black coffee and bananas might have a pH of around 5. And of course 7 is going to be pure water without anything in it. Here we can see some more of those, and we can also look at maybe the basic end of the scale. pH of 8 for raw egg, 9, 10, 12, 14 for our different substances listed there. So just some more examples of higher pH, more basic materials. All right, a neutralization is what happens if we mix an acid and a base together. If we mix an acid and a base together, they will neutralize each other. And that's because the H's produced by the acid and the OH's produced by the base will actually combine and make water, and so they neutralize each other that way. Let's see. So your H plus and your OH minus will come together and make H2O. And of course, when they do, then that produces just a plain water. And of course, then the anion from the acid and the cation from the base, the negative ion from the acid and the positive ion from the base, will attract each other, and that will end up producing the salt, or the an ionic compound. All right, and that is going to, oh, that's not going to, um, salts are a product of neutrals. You thought we were finished. We weren't. I thought we were too for a second, but it will advance, and we'll look at this last slide or two. So again, salts are produced from the positive metal ion from the base, and the negative non-metal ion from the acid, and those will produce the salt. And that is the last slide. All right. Thanks very much. I hope that was helpful. This presentation and this video will both be available on Google Classroom for you to review if you need to. Thanks so much. Bye-bye.